take a look at section 9.2. Okay, it's going to be our last section for the week. It's on ratios, which are basically like fractions, okay, and proportions. Okay, so we're going to go through a few terms that you will need to know for the test, and then some examples.
Should we write these down on our notes?
Yep, your notes will tell you what you need to write.
It's stuff that let's go over right now. I don't have to write anything down.
All right, so we're going to talk about ratios and proportions. Okay, so first thing, what is a ratio? Okay, yeah, that's all it is. It's a comparison of two numbers using division. Okay, and usually we write it as a fraction. All right, so here's an example where you might see it, like if you were cooking. Okay, anybody interested in culinary? Culinary shop, you people? Yeah, in culinary, you use ratios all the time. Okay, when you're making a recipe. All right, let's say you had a recipe and it said you need 3 cups of flour for every 2 cups of water you put in. And maybe you're making like bread or some cookies, something like that. So every time you use 3 cups of flour, you use 2 cups of water. We could write that as a ratio of 3 to 2. 3 cups of flour to 2 cups of water, just like a fraction. Okay, and what this allows us to do is, let's say you wanted to make a bigger batch. Okay, you want to say double the number of cookies you're making, or double the number of loaves of bread. Well, you could also do 6 to 4. If you double how many cups of flour you use, double how many cups of water you use, and you could make a bigger batch. Or likewise, if you wanted a smaller batch, you could use like half of 3, which would be how much? 1.5. And what's half of 2? 1. So if you wanted a small batch, you could just use 1.5 cups of flour to 1 cup of water. Okay, it's all ratios. And cooking is the easiest example I could think of. So these are all the same thing, just bigger and smaller versions.
Guys, that ratio of 3 over 2. Anybody know how else you could write that?
3, 2, 2.
Yep, you could write it in words as a ratio.
Yeah.
3, 2, 2. We probably won't do it.
Did you know?
They're like those 2 dots that you can do.
Yeah.
Yep, that's another way. We're probably not going to use these 2 ways too much, but those are all correct.
Good.
Yep. Anybody seen those before? Yeah, we'll probably do it as a fraction.
The colon portion.
All right, so now if we take 2 ratios, right, basically 2 fractions, like say this one, 7 over 2, and let's take this fraction, x over 3. Okay, and we throw an equal sign between them, okay, just like that. 7 over 2 equals x over 3. Now we get something new. Does anybody know what that's called? 2 fractions equal to each other? It's in the title of the section. That's called a proportion.
So guys, you have that 7 over 2 equals x over 3, and then it says this is called, this fill in the blank with proportion. I just want to show you an example of what a proportion is.
Okay, and let's say, for example, I just look at this. Okay, we all figured this one out together. I could very easily make that just like this one. I could say, the recipe says 3 cups of flour for every 2 cups of water. If I'm going to use 4 cups of water, how many cups of flour? All right, we already know the answer is 6. All right, we figured that out earlier. But that's the kind of problem we could set up. And then we could solve for x. Okay, so that's what we're gonna do. All right. So what I want to do, just look at this proportion. Okay. In general, you're gonna have numbers here a lot of the time. Maybe a letter in one spot. Okay. B and D, though, I guarantee you they will never be a certain number. They can't be 0. Because anytime you have a fraction line, you're never allowed to put 0 in the bottom. How many people already knew that? Can't divide by 0. Yeah, if you try to, watch what happens. The calculator tells you cannot divide by 0. All right, so these numbers in the bottom will never equal 0. Okay, there's a name for, you know what, I'm going to highlight them.
So guys, on your sheet, you have like a couple of blank lines like this. You have a line, equal sign, another line. Fill in the A and the B, the C and the D. And then you have some parentheses. and then you have a couple blanks, then an and in the middle, you're going to write B with the thing that says, with the symbol that means kid equals 0, and you already have the and on there, and the B with the symbol doesn't kid equals 0. You're going to fill those couple things in.
In a proportion, the things that are diagonal from each other have special names. Okay, the first diagonal we're going to look at is the one that starts in the upper left and goes to the lower right. Okay, A and D. Okay, those two things are called the extremes. Okay, so in a proportion, the one in the upper left and the one in the lower right, those are your extremes. Okay, any question on that? So what would be the extremes in that proportion that the box is around right here? 7 and 3. 7 and 3 are what we call the extremes. Questions? All right. What are the other two letters we have on the diagonal in this proportion? What are they? Yeah. Yeah, we've got B and C. Okay. And there's a name for those as well. Those are called the means. All right. This one and this one are called the means. Okay, so you might have a problem on the test that asks you just to do that. Here's a proportion. Tell me what are the extremes, and tell me what the means are. What are the means in this proportion that we have the box around? Corey? X and 2. We didn't say anything about means and extremes always having any numbers. They could be letters. Yep. X and 2. Did anybody have a question on those terms? Extremes, upper left to lower right. Means, go the other way.
So guys, you have on your thing, right? It says type in identify the extremes and means of the proportion. You just have to write it in. It's that same one that's in the box at the beginning of the notes. It's the same thing.
Yeah, so it's the one, we already did it together. We just did it. Alex, can you remind me here, what are my extremes?
7 and 3.
Yep. And my means?
2 and X.
2 and X. That's it. Okay, later on, we're actually going to solve for X. Okay, this problem, though, you don't have to find what X is. Just identify the means and extremes. Okay, let's do the same thing right here. Take this. All right, so take a second, look at it, see if you can figure out the extremes and the means.
So guys, you have a space for 1B. You just have to write it in.
Okay, how about Ben? Can you tell me what my extremes are?
X and 9.
Are those on a diagonal from each other?
No.
Nope. Remember, they're always on the diagonal. Right? Just like that. So these are two different things.
So it'd be X and 5.
Yeah, X and 5. All right, and Jalen, how about my means?
9 and 4.
Yeah, 9 and 4. Okay, any question on that one? All right. So now what we're going to try to get into is solving a proportion, okay? Finding out what does the letter actually equal. And we're going to use what's called the proportion property. And it basically says, okay, for all numbers, A, B, C, and D, okay, you can use any numbers you want. Could be fractions, could be decimals, could be positive, negative. The only thing you can't use for B and D is which number? Can't use 0 because that'd be dividing by 0. So we'll never give you one where there's a 0. Okay? But any other numbers that you want for A, B, C, and D. If you take A times D, which, what are those called again? Those are the extremes. And then you take B times C, what are those called? The means. They come out equal. Okay, that always happens. A times D has to equal B times C. Okay, in fact, I can show you with one proportion we had earlier. Okay. What's 3 times 4? 12. What's 2 times 6?
12.
There you go. They always come out the same. So that's what we just said. When you multiply the extremes, okay, you get the product. That's equal to when you get the product of the means. Right.
So you guys have the proportion property written on your thing. It's already typed on there for you. So you have to write that stuff after so. So that's basically like we get off for the proportion property. You have all like these different letters, and this can equal this, and that can equal this. As long as you know that when you multiply the extremes and multiply the means, they have to be equal. They'll be equal to each other. That's what basically what all those letters and stuff in the proportion property. That's what it's saying. So on the front side, you're going to fill in those 2 lines.
And that's what that means.
And you have the little diagram on your note sheet, right? A was again like we're kind of like cross multiplying. A times D, B times C.
Yeah, in fact, that was going to be my next question. If anybody knows what that is called when you multiply on the diagonal, it's called cross multiplying. Yep. Okay, does everybody have that?
No.
No? Okay, how many people remember doing that kind of stuff before? You've solved proportions, you've used the words cross multiply. All right, so if you've done it, it might be a little bit of review. Okay, if you haven't, we'll go through a few examples, and then at the end, we'll try a couple word problems. Maybe like a cooking one, okay, if we have some time.
So guys, we're gonna go once you've written in all that stuff. All right, we're gonna go to the back side.
All right, so first one we're going to look at is 2 divided by x equals 3 divided by x plus 6. Okay, this one's a little bit more advanced than a real basic one. But we can take a look at it.
Okay, why don't we go back to that? Maybe we want to go back to that 1b. Because we found the extremes and means for that one, but we didn't solve it.
Yeah, we didn't solve it. Let's start out, we're going to still do 2a.
Yeah. Cool.
So keep that there.
We're flipping back and forth. Sorry, guys. Let's go back to 1b because we found the extremes and means for that one, but we didn't solve it. We'll start with the basic one before we go to the more advanced.
Yeah, we'll solve this one. You just got 3 numbers, 1 letter. A little easier. All right, so remember what the step said to do. You're going to multiply the extremes together. Anybody tell me what you get when you multiply x times 5? 5x. Then we're going to multiply 9 times 4, which is how much? 36. And what goes between them? Yeah, equals. Put an equal sign right between them. And that's it for like a new step. Now, hopefully remember how to solve that for x. What's my last step to get x by itself? Divide by 5. You're done. That's the whole problem. Don't even worry about changing it to a decimal. So that's the solution to example 1b. They didn't ask you to do that in the directions, but we wanted to start out with an easier one. 2a isn't too hard, but it's a little more work. You guys want to try one more of the easy ones? One more? Okay. Let's try this one. What's 7 times 3? 21. Equals, Maria, what's 2 times x? 2x. And my last step to get x alone. Divide by 2. Divide by 2. X equals 21 over 2. That's it. That's all there is to solving proportions. Okay. People feel okay with those type? Where you got 3 numbers in 1 letter? Okay with those? All right. So now let's go back to 2a. Okay, so this one's got a number. It's got a number, but it's got a couple letters. Okay, one thing Mr. Roy and I will not do is put the letters on a diagonal from each other. That would make it a different level of problem. We're going to keep the letters either both in the bottom or both in the top. You won't have letters on a diagonal. Okay, that would be a little harder. All right, so one of these things kind of stands out. Which one of these things looks a little different than all the others? You got the 2, the x, the 3, and then x plus 6. Yep, all right. Yeah, the x plus 6, it's got 2 things in it. Okay? So whenever you have something that has more than one term, this is step 1 right away. Okay? Put parentheses around this. Okay, the reason why we got to put parentheses is because when we multiply on the diagonal, it's going to end up being a distributive property. You don't just multiply the 2 times the x, you also multiply the 2 times the 6. So we're putting those parentheses to hopefully remind you of that. That's the only extra step for this problem. That's it. Right, so what I like to do, I just circle, okay, what I'm going to multiply. Does anybody else do that? They just circle what they're going to multiply? You use some kind of color, yeah. You don't have to, but it sometimes helps some people. All right? So anybody just tell me in words, what does this mean to do? Just tell me what that says. Yeah? Multiply what times what?
2 times x and 2 times 6.
Yeah, exactly. 2 times that whole thing, x plus 6, and you said, perfect, we're going to distribute. Equals. Sam, can you tell me what are the other 2 things I multiply? Yep. X and 3. And you get 3x. Okay, once you do that, now we've got a pretty basic equation. We've solved equations a lot harder than this. All right. Victor, what's my first step with this 2?
Distribute.
Yep. And can you distribute, tell me what 2 times x is?
Plus 12.
Plus 12. Nice. All right. And now we got, I think, 1 step left, and then we're done. This one's actually going to be pretty fast. Davin, can you tell me my last step? We've got x's on both sides, right?
Oh,
So we got to get all the x's on one side.
so would you put 2x under the 3?
Okay, how would you move it? Would you add it or subtract it?
Subtract.
Yeah, you want to subtract it. Because this 2x is positive. We're going to subtract it to cancel it out. Okay, and on the left-hand side, Logan, what's on the left side now?
The left side is just 12,
And the right side?
3x.
I don't think it's 3x.
Sorry.
If you don't want to.
1x. Yeah, just x. Okay, and that's it. The answer here is 12. Now we could check it. We could plug it in and you could see. What's 12 plus 6? If we plug 12 in for x? 18. What's 18 times 2? 36. Okay, so that came out to 36. What's 12 times 3? 36. Right? So it came out the same. So that means the answer works. Both came out to 36. Okay, questions on that one? That one's a little bit harder than the last type. Okay, same basic type. Number in the top, numbers in the top, letters in the bottom. All right, anybody tell me what's my first thing I do? Kind of guided you guys through it a little bit. Somebody tell me. First thing I do. Zach?
Put 6.
Yeah, I like that idea. Put parentheses around a plus 3. Perfect. Exactly the first thing you want to do. Okay, so Zach started us off. Who can tell me what I do next? Everybody feel confident? Maria?
You need to rewrite it to 4 parentheses a plus 3
All right,
equals 6a.
I like it. Okay, so she did 4 in parentheses, a plus 3 equals 6a. What property is that on the left-hand side we're going to use right now? Distributive. Yeah. And Ryan, can you distribute that out for me? Tell me what I get.
4 times a would be 4a,
Nice.
and then 4 times 3 would be 12.
Positive or negative?
Positive.
Yeah, because it's positive 12. Now, do I distribute that 4 to what's on the other side?
No.
No. All right, I think we got 2 steps left. About rows. You see what we do next?
You subtract the 4a from 6a.
Subtract the 4a from 6a.
And 4a.
Good. And the 4a. 4a, take away 4a, that's gone. And Rose, bless you, can you tell me what's left here?
12 equals 2.
12 equals what?
2.
2a. Nice. Okay, and we're at our last step. Yeah, all right. Divide by 2. And divide by 2. Okay, so what is a here? A is 12 divided by 2, or 6. Do you guys want to try one more of that type? With like a negative? Anybody feel like they want to try one more? We're okay with that? Okay. We'll go on because I think we got a couple word problems to get to too. So, all right. Just going to have to remember when you distribute here, you're going to have that negative 5 times a. But then what about when you do negative 5 times negative 4? That becomes a positive 20. Don't get tricked by that. Okay? And then the other one would just be 3 times a. Just 3a. All right, so let's try a couple word problems. Okay, and we're going to show you guys how you can set this up. Do you already have this written? Yeah, good. All right. So this says a recipe for 3.5 dozen muffins. Okay, so that's probably important. 3.5 dozen. So you know what I'm going to do? I'm just going to group that together. 3.5 dozen needs 700 grams of flour. Okay, so to make 3.5 dozen muffins, we need 700 grams of flour. They want to know how many dozen muffins, that's the question. How many dozen muffins can we make if we use a little bit more flour? Okay, if we use 800 grams. So obviously, if we can make 3.5 dozen with 700, we can make even more with 800. If we use more flour, we can make more. Okay, so we're going to set up a proportion. Okay, so the way you want to set it up, start by going like this. Put a line, put an equals, put another line. Okay, there's really two things in this problem that have labels. Okay, anybody tell me what are the two things here in terms of numbers that have labels or have some kind of meaning? Can you tell me one of them? Yep.
The flower.
Yeah. Okay, we have a number that's attached to flour. Okay, so flour is one thing. And what's the other number that has a label? Yep. Yep, that's the flour. So the 700 grams is flour, the 800 grams is flour. They're both flour. Something else has a label too. Dozen. Okay, 3.5 dozen. So the two labels you're working with in this problem are dozen and flour. Questions on why those are the two quantities you're working with? All right, and what we're going to do is take each of those quantities, and we're going to put them on each side of this proportion. All right, so what I'm going to do is I'm going to write dozen in the top. I'm going to put flour in the bottom. Now, I could have switched that. I could have put flour in the top. I could have put dozen in the bottom. All right? But what's important is that however you do it on the left, you have to do it exactly the same way on the right. So what's going to go in the top on the right? Dozen. Why? Because you have to do exactly what you did on the left, and dozen was in the top. Okay, what's going to go in the bottom on the right? Flour. How come? Because it's in the bottom on the left. Dozen, flour, dozen, flour. Now, when we fill this in, 3 of these things should be numbers. Okay, I see 3 numbers up here. One of them should be a letter, something we don't know. All right, let's start with the first dozen we see, 3.5 dozen. 3.5 dozen. How much flour do you use for 3.5 dozen? That's what we need to fill in right here. 700. Does everyone see where he got that from? 3.5 dozen requires 700 of the flour. 3.5 dozen requires 700 of the flour. Okay, so that's our left side. Now on the right side, what do we have a number for we can fill in? We've already used this. We've already used that. What's the other number we have? Yep, Alexis? 800. And is that 800, does that go with dozen or does it go with flour? How do you know it goes with flour? Yeah, it says 800 of the flour. Okay, that's the flour. So the question is, how many dozen? That's what we don't know. How many dozen? So what should we put here? Yeah, we should put X. Okay, and that's the hard part. Okay, setting up our proportion. Now, what I usually like to do is rewrite it so I don't have the labels. Okay, just write 3.5 over 700 equals X over 800. Okay, I just think it looks a little simpler. It's up to you. All right, now how am I going to figure that out? What do I do next? Oh, Kevin? What do we do next? Does this look like anything we did earlier? Like example 1A or 1B? Where you got 3 numbers and then a letter in one spot?
Times the 3.5.
Mm-hmm. By, yeah, the 800. Perfect. So you're going to times 3.5, which, what's 3.5 as a decimal? Yeah, why don't we just write it as 3.5? 3.5. It's going to be easier to type in the calculator that way. Okay, so 3.5 times 800. Okay. What's going to come after that? What symbol do we put next? Yep, equals. And Gabe, what goes on the other side?
700x.
Yeah, nice job. 700 times x. All right, now I gotta solve that for x. Michaela, can you tell me what do I do first here? Multiply, what'd you say? Yeah, the 3.5 and the 800. All right, so we got 3.5 times 800 gives me 2,800 equals 700x. And now I want to get x by itself. So my last step. How about Ryan? You tell me my last step here to get x by itself?
Divide 700 both sides.
Yeah, nice. Divide each side by 700. Divide by 700. And we can use our calculator, but does anybody know what that comes out to? Give you a hint. If you got a 0 in the top and bottom, you can cross it off. Top and bottom again, so really it's 28 divided by 7. It's going to come out, I think it's going to come out nice. Yeah? 4. So x equals 4. Now, what was x? What should be our label here? Dozen. X dozen. Okay, now we know it's 4. So anytime you solve a word problem, always go back, make sure you put that label. 4 dozen. Any questions on that? All right, so we'll have you guys try one more word problem with Mr. Roy.
Yep. All right, so guys, very similar. All right. It says a recent poll found that 7 out of 8 people use no Cabot toothpaste. How many people can be expected to use this brand in a city of 40,000 people? All right. So, what's one thing or one piece of information in the problem that's going to be important? Caitlin.
7 out of 8.
Okay. Well, what do you want to do with that, Caitlin? Put it as a fraction, right? So how would I write that?
7 over 8.
7 over 8, right? That's like we talked about at the beginning. All right? 7 out of 8.
And what would be your labels here? Because you don't have flour and dozen. 7 people what? Yep. So yeah, I'd put 7 people use. So you're going to have use in the top. And what's 8? 7 out of 8. 8 is the what? Yeah, it's the whole. It's total. So maybe total in the bottom. So we're going to do use over total out of use over total. I think that one's a little tricky, but that's how I would think about it.
Because this was the total amount of people polled. All right? So like Mr. Hager said, use over total. Davin, do you think, so what's the only, so we used the 7 out of 8. That's, we don't have to worry about that anymore. What's the only other piece of information in that problem that might be helpful? All right, so you got 2 choices. Where do you want to put it? With the people that use it or the total number of people?
Use it.
Because how many people can be expected to use this brand in a city of 40,000? 40,000, that's the total amount of people living in that city. Right, 40,000. What's the only other thing I have to put? Just the X, right? It's just asking us how many people, right? We don't know how many people use it, but like Davin told us, out of a city of 40,000, that's the total amount of people living in that city. All right? Mr. Glenn, what are we going to do?
Multiply you'd write 7 times 40,000.
7, I'm gonna put parentheses, is that okay?
Equals 8x.
Did you do this?
Yeah,
Did you get?
no, I didn't do it.
You didn't do it yet? Let's see, let's get a, I know it's on here somewhere. What's on it?
280,000.
280,000. On the other side, what's on the other side? Right here, this 8x. Sabrina, what's the last step? Divide by 8, right? X equals what? $35,000 people what? They use it, right? So 35,000 people use no Cabot toothpaste. All right? So tonight on your homework, you'll have one word problem. Right? There'll be one on there. It won't be like this many people out of this many people. It'll be more like the first one that we did. All right? Everybody, guys, can I move on? We okay with this? Everybody's got it? All right. So tonight, homework. You got to do 9.2 worksheet. It's only 7 problems. All right? The first couple, you're going to have to identify the extreme and the means. All right? You might want to leave those notes out because you're still going to need them. All right? You have to identify the extremes and the means and solve, then solve a couple, and then do the word problem. Remember, like I told you at the beginning of class, test on Friday. 4-7, which is percent problems. 4-8, which is what we did yesterday, the different formulas. And then 9-2, which was proportions and ratios that we did today. And we got some practice problems for you guys to do next. Remember, tomorrow is all review. Nothing new, just like last academic week, nothing new tomorrow. Right, like Mr. Hager just added, right, there's a bonus problem in the video.
And that's for the test
For the test.
on Friday. Right, so the bonus problem for the test on Friday this week, October 2nd, is to write down your answer from example 2 from lesson 4.8. That was on September 29th this week. Okay, September 29th was Tuesday. Okay, so make sure you write that down on the test. Okay, we will have you write down your answer to the above problem. Okay, the actual problem will not be on the test, so you need to copy down just your answer. Okay, that's the only thing you need to copy down from that example, just your answer to the above question onto your test review sheet. Okay, you will not be allowed to look back in your notes or ask myself or Mr. Roy for the actual problem the day of the test.